Okay. So hopefully the music's not too loud. It seems like it should be fine. Oop, shoot. Hold on. Hold on. Okay, so I guess one thing I want to do is I want to go through and actually see what all the solutions are for this. Because Mocus Mo, apparently it's Tim Nicholson is his name. Anyway, I still haven't played his game. It's literally here. Anyway, Mocus Mo says that there are 5 solutions to this puzzle, and I kind of want to have less solutions. He said there's 3 to this one, and 1 to that one, and 1 to that one. So I'd like to have 1, 1, 1, 1, ideally. As he said, not counting reflections, rotations, inversions, whatever. So what I've been trying to do is figure out the other solutions here. Since I haven't written a thing that just like brute force solves these and figures it out, I kind of have to figure it out. Now, I don't really know. I'm not sure what the other solutions here are. Because I can't actually figure out what they would be. Because just based on the rules, I can't toggle these, so that means that if I'm going to connect these, I have to kind of do like this or something. I guess I could do like that, and then like that, but then I still got 2 here, and well, I could separate 2 there and do 2 there. Okay, so there's a weird one. So I'd like to ideally eliminate the weird ones. Hello, Justy989. How are you doing today? We're trying to eliminate weird, wonky solutions to these without being too restrictive. So I'm just going to take a screenshot of each solution, because that seems like the easiest thing. So obviously the solution that I wanted here is like, this one's supposed to be pretty easy to solve, because you just need to connect the adjacent ones here, right? Whereas this one's supposed to be a little harder, because I can't really do that. Because there's just no way to do the same thing. So I have to figure out what I can do. So that doesn't work because then those are connected. So it feels like they're all going to be wonky kind of solutions. Like the one that's sort of intended is this one, I think. No. What is it? That. Well, there's one. It's different. I think you can also do this. No, you can't do that. Cannot do that. I don't think there's any way to actually do that. that because that converts there. Let's see. It might be good to do the brute force solver for this kind of thing. I don't mind if they're interesting alternate solutions, but if they're like alternate solutions that are really just bizarre, then I'd rather not have that. This one has a lot of solutions, actually. Whereas the one that I wanted here was this, I think. What is it? Yeah, I wanted this to be the solution there. But it has a lot of weird ones on that. You can't do this, I don't think, but you can do like... Let's see, because this has always got to be connected with something. So you can connect it with like that. I actually didn't mind the idea of it being having a puzzle that was like this and required you to like connect stuff, but that doesn't really work here, so. Supposed to be looking for ones for this one because this is the one that had the most according to Tim Nicholson here. So this had, well, I guess it didn't have the most. He just said it had 3. I found 2. Well, found 2, one being more or less the one that I intended. So there's that one. I don't know what the other one is. Can't connect in the middle. Even if I just have to have this one and this one, those are both good puzzles, so... Like, this one's good because it's kind of like a basic thing. And this one's good because it's a really non-obvious thing to do. Now, the weird ones here, I think, involved... Damn. That's tough to figure out. Involved doing, like, that kind of thing. Yeah. So that's a weird one for that one. So the main thing is like figuring out what constraints I have to put to make it to where... I mean, that's not too degenerate, so maybe I should leave it anyway because it's still tricky, but I don't know. I mean, I liked this solution. Like, that's a really good solution. But there's nothing that says that that's more right than anything else, so... But yeah, it was like kind of the point that I was thinking was that that would play off of this one, right? Because you got this one where I have to divide it into the 4 quadrants, and then this one I can't divide it into the 4 quadrants because there's only one in each one of these. Two there's, 2 there's, 2 there's, 2 here. There's only 1 there. Now I'm just leading into this one. So I'm trying to figure out can't do that way, no matter what. I can't connect to that one. Well, I guess I can. I just can't then also connect the other one to that. Another weird one. So there's like quite a few weird ones with that. I really need to there's some way that I could have this debug log, like I could click it and it would take me to the screenshot. That would be nice. So as is, I gotta go in here to screenshots and look it up. Okay, so what do we got here? Unfortunately, the game also auto takes screenshots, so. So we got a weird one there for that. I'm just gonna pull these into Photoshop. That way I can just set them up side by side. Ugh. So we've got 1, 2. Those are the only solutions I found there. Actually, that's the same solution there. Okay, that's a solution. I think it's a rotation now. I don't know. Anyway, we'll pull these in. Those are really the only 2 that I see there. I don't think that's the same panel, is it? No, it isn't. So that's a different panel. well. Alright, so let's say we got that and that. So one of these is the intended solution and one of them is not. This is kind of a solution that I like, and this is a solution that I don't like. What is the difference? The difference is that this one's lit right here instead of this one. That's literally the only difference. So, question then becomes, what other solutions are there? So I was told there are 3. I don't know if that's actually true, but I was told that there were 3. Because I've got the intended solution, which is this. I've got this solution. That doesn't work. I think this is, well, should I do the thing that finds the solutions? God, I've got too many things open here. Oops. I want to close all of it. Alright. So finding all the solutions. I basically need to pull out this solved thing into its separate thing. I'm gonna see if I can pull that out. Okay, so I'm gonna try pulling that out into a function that's called check for solutions. It's gonna go solved is equal to check for solutions. We don't need that because it's going to return. So we're going to try doing this and see if that'll work. Public bool check for solutions. And then we go through here. We start with solved is true. We go through, continue, solved equals false. I'll still put a label. We'll still do it with a label. End of solution checking. Label. And we'll go return solved. So I have literally no idea whether that will work. But we're going to see if it will. Okay, it seems like it still works, so that's good. So that means that I can actually just check for solutions. So then to do a function that, well, it's not even check for solutions. I need to like, it's just like is solved. Because then this is going to be public. Should it return something? Should it return the list, or should it just store the list as part of the thing? I think for now I'm just going to store the list. So it's going to be find all solutions. So I need to let's see, how do I check every possible state? I feel like that's a recursive function. Actually never done that. I've never just like written something that goes through and iterates through every possible permutation of something. How do I do that? It's just ones and zeros. How do I do that? Does anybody know how I do that? I could Google it, but it seems more interesting to try to solve it. Because I might be able to do it without recursion. I'm just trying to think of what I do. If I thought of it as just array of packed bits, then really all I have to do is take the maximum amount of bits that I have and just churn through all of the numbers, like bitwise. Just like add one bit, add one bit, add one bit, add one bit, and check everything, and eventually, and I'll go through everything. But I can't think of a better way of doing that. Because basically I would need to do like, we're just gonna like pseudo it out, I guess, because I need to do for each basically for each tile, I need to So I need to check it on, check on, and for each other tile. And this is surprisingly hard for me to wrap my mind around. To just check everything, because if I can have every state, then I can just punch a state in here, right? To is solved, and get whether that's a solved state or not. What is it? So I need to check it on and check every other tile on. How do I do this? Okay, if I check it on, I check every other tile on. And then I check it off and I check every other tile on. And then leave it off? I don't know. I'm just gonna have to Google this. See, find every permutation. That's ordering. I don't care about ordering. I guess. So, doing permutations, they used recursion. But that's not really what I'm thinking. Not really the kind of algorithm I need. Like, I'm not really interested in order of something. I'm interested in all, like, possibilities. Like, like, what do you even call that? It's not a permutation. It's like, is it this? Not helping me. Like it's not a permutation because of what, like, permutation is about ordering, right? Or it's like I've got 1, 2, 3, 4 and they can be in different orders. I don't have 1, 2, 3, 4 in different orders. I just have a set of things that could be 1 or 0. So feels like I just need to basically, let's say, yeah, it would kind of be like for each tile. Ugh. Problem is trying to wrap my mind around which ones I've already covered, so I don't check one more than once. Because say like I have the first one, I've got the game to do this, so why don't I just do it in the game? Okay, so say like I'm checking this, I check the first one. Like, okay, I turn it on, right? So then I can turn the next one on, and then turn that off. And then turn the next one on, and then turn that on, and turn that off. And then turn the next one on, turn that on, turn that off. But then I have to check that too, so it's basically got to be like... because I have to check all of those, right? Trying to think of how to... It's not going to work though, because it's still not covering everything, because even if I check that, I still haven't gotten like that, and that, and that, and that. Those are all different sub-combinations, so... So yeah, it's got to be, you go through all of them and check them on or off. Well, off isn't anything, so we just check on, basically. For every single one, we check on. And then we move to on. And then for every single one of them, we check on. Is that gonna work? It's like, what if I get to the end here? Like, I'm gonna have... Yeah, because I'm still gonna miss, like, this. Like, that's not ever gonna get tested, because I'm gonna test this. So I have to do, like... I have to, for each one, I have to test that, basically. And then move to that. Okay, so that is recursive. So it's going to be like for each tile, check on for each other tile, check on, and then it's going to be like recursive, I would think. Basically. So each time I make the list a little smaller of tiles to visit. Feels like that will work. So I just need to make a list. Make a list of, I guess it's an array list of shit, tile positions really, but this is hard to figure out. So I don't really need that. I just need a bool array that's like checked tiles like this. I don't really need the list, and then I need to go through for each God, this is brutal. Sort of like go through this in current state. Need to have an index into it though, so I really need to do like for int I equals 0, I is less than guess that would be X, though. But it doesn't really matter, because I don't really care about the thing there. And that's probably going to be off by 1. Maybe off by 1. And then I++ at the end there. So first I need to go current state is equal to new bool width times height. We're going to just go through all of them. Then I'm going to set current state I is equal to true. Then I need to go through wait a second. Current state I is equal to true. Check tiles I is equal to true. Because then I need to kind of recurse back through. Because I need to basically at this point, I can't just check all of them. Okay, so I need to hello, offender. I am probably spending more time on something than I should be. So I thought maybe I would write this thing that finds all the solutions of the panel. But the thing that's actually the challenging part for me is not finding all the solutions, but iterating through all the possible combinations of the panel. Because I basically just have a list, or just an array, a flat array of, let's just say bools for the sake of argument. They're not, but they're 1 or 0, right? And I need to go through all the permutations of that. And then I can just feed that into my solution checking algorithm for every single state to see whether or not it's a solution. And that's the thing I'm just not braining right now. Because basically I need to, for every single tile on the grid, like what I need to do like I'm not trying to figure out whether the panel's solved. That's not an issue. The issue is just if I have a panel, I need to go through all the permutations of the panel. And symbols care about tiles that don't have symbols on them, so So I'm just trying to think how to do this, because basically I need to test like every one of these, right? Like this. Like we won't even worry about the locked tiles. We'll just say, yeah. So I just need to test every single one of these, right? Which is like, that's just iterate over each one and try each one. And then I need to also like test every single one of these, right? But I also need to test more than that, because I need to test like this. So it's like I need to test this, and then I need to test this, and I need to test this, and I need to test this, right? So I need to test like every single combinatoric of everything, and I'm not sure how to do it. No, that won't work. Yeah, the way these things work is not that simple. And also the figuring out whether it's solved or not is not an issue, right? Like for these guys, I just iterate through to find the area of this that's filled, right? And then I check certain things about that. Like in this case, I check to make sure that there were only 2 symbols in that area. So I can check to see whether or not a certain state is solved. The problem is I need to set the panel into every single state that it could possibly be in order to find all the solutions that there could possibly be for the panel. Like that's what I'm trying to do. I'm trying to write like a brute force solver for the panel, not a solution checker. Like the solution checker works fine. The solution checker for whatever reason was easier for me to figure out, even though it's like a recursive thing right here, right? Like this is the thing that I use to find those areas. So I just need to do the iteration of all the possible states that the panel could be in, which I'm sure I could find an algorithm for on the internet, but I have no idea what you even call this, because it's not permutations, because permutations is like shuffling things around, and I'm not shuffling things around. I just need to find all the states. If I can just do bitwise, then like it's literally just going through all the binary addition, right? It doesn't matter about performance. Like it's just a tool for me on the back end. If I get to a point where I'm like, I'm pretty happy with this panel, right? The issue I've had is I was pretty happy with these, and then I've had this guy who went and tried and figured out like that this panel actually has like 5 different solutions, and so I've went through and figured out that there's a bunch of degenerate weird solutions that are not like what I wanted the solution to be, or it's not so much like here's a weird degenerate one, right? Like what I the actual solution I was thinking of was this solution, and there's some weird like messy ones, and so it would be nice to be able to like do that. Yes, I can make it manually. I just don't know how is the problem. Like, I don't... That's the issue, is I can't figure out how I can actually write the thing that's going to do that, because I've never written anything that does something like that, that just tries every combination. Because I'm just trying to even think of how I write that loop, right? Because it's got to be some recursive thing, but I'm trying to figure out, like, what it is. Like, I understand even to a point of, okay, it's got to go through each one, and it's got to go through each one, and it's got to go through each one, and it's got to go through each one. But I don't really... get that. Like... like, I'm not... It's not computing in my brain how to do it. It's maybe not a good thing to have tried to figure out on the stream, but, like, because it's definitely, like, for each one of the tiles, I want to check for each one of the rest of the tiles. I want to check for each one of the rest of the tiles. I want to check for each, like, it's some recursive thing. I'm just trying to think of how it is, right? Let's see. Like, yeah, like... It's a simple thing to say, well, yeah, can I not just test every possible combination? It's like, yeah, but how do I, like, loop through every possible combination and not, like, cover it? Because the dumbest thing I can think of is, like, okay, we toggle that on, right? And then we move to the next one, we move to the next one. But if I then say, okay, now that's on, and then go to the next one, like, that's not going to cover certain things, because I'm going to eventually, like, say halfway, I get here, and then I'm still doing this, but now I've missed, like, this, or this, right? Like, I've missed all these combinations. Like, I missed all these things that have weird gaps in them. It's a difficult question. Interesting question, but difficult. Anyway, the other thing I was looking at was just what the weird degenerate solutions were. Yeah, that's kind of what I assume I'm going to do, is just have to type in a bunch of random crap. Let's see. Because I have to figure out something, because if I just do, like, I can't just kind of iterate through and say, well, that's going to solve it, and, well, if we did this, well, that's going to solve it, because it's not really. said, the only thing I could think of was just bitwise, where you like. Something like bitwise. Do they have like a bit field in C#? I don't even know if they do. Oh, Jesus. Oh my God. Stack Overflow is being useless as usual. Here we go. There's a bit array class. Doesn't really help though, because like because like if I can theoretically, like if I'm talking about like my array is basically like this, then that just means that it's a number, right? Like it's just data, and if I add like 1 to that, right, like we add 1 to that, oops, darn it, so we add 1 to it, then it's going to be like 1, right? And then it's going to go 0, and then it's going to, we add 1 there, and it's going to go 0 and 1. And so eventually you iterate through everything due to the way that that overflows, right? So let's see. So how would I do that anyway? Because if it's like... Wait. Yeah. I'm just trying to, like, get my mind around the problem. Okay, so essentially the way that does is it takes for each one, it goes through, and then it will set it to 1. Okay. This is really destroying my brain right now. Even at that, I think I missed one in here when I was fooling through it. Because there should have been... Yeah, there should have been this one as well. So we need basically to keep track of like our leading bit. Position, right? I feel like. But it just feels so much like I can just do this with a bitwise. The problem is I don't know how to get... I guess I can get it out like this, but that seems really dirty. It also means that if I'm using the CPU to do that, then I've only got like 64 bits, which limits me on the size of things that I can solve that way. I mean, I guess I can do like double longs and still do it. It just won't fit in the registers. Not that I should even worry about registers, because C# probably doesn't even like actually use any of this stuff, but so I can make a bit array this way, because this says that I can do this, which is probably slow, but the easiest way to do it. So like if I take the problem is I want to convert a bit array essentially into convert bit array to like an int, right? Okay, so if I just return the array accessor as an integer, then it would work. That is such a shitty way to do it, though. That's such a shitty way to do it. I'm gonna run out of time and have to go to work and have done nothing. But this is kind of what I wanted to do anyway. I just don't really want to do it with a bit array. It seems like such a stupid way to do it. Like, part of me wants to do that because, like, well, the CPU can do bitwise operations. Because I could just do it this way, where I have like unsigned long I equals 0, and then I could just go essentially do this every time, and then I can bit array it this way, right? And for each bool b and ba, if b, the problem is I can't just do that, right? Ugh. Damn it. Sorry, let's see. Oh, I don't need to split it over multiple frames or anything like that. Like, it doesn't matter. It just has to work and find all of them. It doesn't have to be performant. It doesn't have to go over multiple frames. It can take 3 seconds. I don't care. Like I said, it's just a back-end tool for me to just be like, I want to see all the solutions for this puzzle. I think I've seen all of them, but maybe I haven't, and maybe there's some weird degenerate one. Because I can't figure it out what it would be recursively, like what am I doing every time I recurse? I can't figure that out. Like, because the only thing I could figure out just basically kicked the can down the road. Yeah, I know that. Like, if I set it and then do it with the next tile, I just don't know what the thing I do is, because it's like, if it's like kick the can down the road, then let me look. Sadly, I don't have the Twitch thing open. Can you just post that real quick again? Offender, so that I can just like. Okay, thanks. I don't think that works, because I think that the problem with that is the problem I was talking about, because what you're saying is the first thing I thought of, which, let me just make a plain grid, or even like a straight line, it doesn't matter, like, let's make it a 10 by 1 or whatever, right? Like, I don't think that'll work, because what you're saying is, essentially, we do like this. If that's not on the list, then we add it to the list. Then we go to the next one, toggle that. If that's not on the list, we add it to the list. Right? Okay, so we're just going through like this, right? Adding each of those. And then doing this, right, is what you're saying. So, what, like, Okay. Well, that would work, but I agree with Mokasmo that it kind of has the same issue, which was why I was taking so long to think about it, is that exactly, it's a brute force way to toggle every single tile, I think. And I have to keep track of a list of configurations and compare it to the list to make sure that I'm not like multiple covering the thing. I can try that. I don't think it will work, and I unfortunately have no way to validate that it actually will work. Like, I don't have something to compare to be like, therefore it did find everything. I guess I can compare the count, which I do know, like, combinatorically what it should be, right? What would that be? Like, if it's 10 tiles, then it would be like, wouldn't it be like 10 squared? So there should be like 100 combinations. Anyway. Alright, so I'll implement this, I guess. So we're going through I. Unfortunately, let's see. The easiest thing to do would be make a... Actually, I don't even know if current state is a bool. I think current state's an integer right now, so I'll have to make a b of it. Okay. So it doesn't have to be an integer, so we're just going to go b current state. And so it's going to be... b current state is equal to not b current state, basically. So that toggles, right? Alright, let's see what Moxmo thinks. Okay. I'm just trying to see how this works. It seems like it should work. Should toggle itself and check twice. You mean like just check the opposite for each one? Okay, let's see. I don't know what to call this. Oh, it doesn't change the last tile ever. Well, it's the same with me, right? But sometimes I come up with something that's pretty good. Like this recursive thing to find everything in an area was actually pretty good. But that was because it like employed my spatial reasoning, which is pretty good. So, so okay. Ugh. So let me just do this. If current state I plus 1, I'm not going to use n, I don't think, exists. Is exists even a thing? I don't think that is. So I really just need to, I don't even need to check that. I just need to check if I is less than width times height. I should be able to do it -1 to fix your thing. But, okay. Okay, that's fine. So then that's current state I is equal to 0. So I should be able to do this, right? Basically. Yeah, well, that's simple enough. I was mostly worried about just the straight brute force thing, and then we'll worry about the broken tiles or non-existent or whatever. I think it's basically having had experience with recursion. Whereas, like, for me, that thing that I wrote up there is, like, one of the only recursive things that I've ever written. I don't know. We'll just go, like, we'll pull this out into something else. It's like public. I don't know. We'll just go like this. For now. Recursive tile iterator. I don't know what to call it. And then we'll pull this in here. Probably needs I, right? Yeah. Int index, or int I. And then recursive tile iterator. I plus 1. Current state I equals 1. Recursive tile iterator. I plus 1. Else. Yeah, okay, yeah. Current state I equals 0. If is solved. If it's solved, then we want to basically add it to a list. Solution list. How does that work? Add. I don't know how that works for array lists. I have them somewhere here. Array list. Check tile list. Add. Okay. So I should be able to add that, hopefully. Which would be current state. Hopefully. I don't know if that copies or what it does, but let's see. It's certainly more than I can think of it, because, like, I understand it from a standpoint of, like, find everything where it's on, but that's what I was saying about, like, if I think, oh, well, I can't figure it out for the first tile, adding the recursion when I can't figure it out for the first tile is, like, just kicking the can down the road, where it's like, I still don't know what it is, but we're, like, going to keep track of a list and compare all the things on the list to make sure that I don't, like, go over the next thing. But yeah, that should be it. And then yeah. do it with I can do like a bool array list, right? I feel like. I'm not sure though. Array list, bool array, solution list. Cursor tile iterator. I 0 I ref solution list. This is the thing that I'm not sure about. Syntactically and all that, what I can or can't do. Obviously I forgot semicolons because I always do that. The non-generic type system collections array list cannot be used with the type arguments. That is a really useless error message, I gotta be honest. So do I just do this? So as an array list, not. Okay. Let me go back and look at my usage of array lists. Okay, so I have to make it a new. I have to new it is the problem. So this has to be like new array list. Oh shit. So do I pass it down the chain or do I just use it as... I'll just do it this way. This will be easier. And then I'll just do this, and then we won't have to pass it down the chain. Okay. So that appears to work. And so it should go through and add the things to that, right? Theoretically. Alright, so now I just need to add something to the editor for that to actually let me call it, basically. So, where do I want to put that? I'll just put it under solution state, I guess. So that's going to be like find all solutions. And then we're going to go find all solutions. Okay. The basic thing that I would need is to be able to set it to one of those solutions, though. Thanks, Offender. I mean, it helps me a lot, right? Yeah, I will need a separate case to account for that, but I'm really just concerned about, like... Like, I'm mostly just concerned about the basic case. Like at this point, to do this is not that hard because I basically just add an extra thing that's like an extra if, right? So if it's here, then it's like, okay, well, if it's locked, then we just don't toggle it, basically, right? We just kind of go to the next one, right? And that if it is locked, if it's locked, then we just go to the next one, right? We just skip skip that index, basically. Yeah, I'll worry about whether or not it causes like Unity to explode after I actually get it clearly working. We'll just go like this, because this is probably the easiest way to just do something to see whether or not it found a solution. Which would be panel dot solution list. I think I can index them this way, but I'm not really sure. 0. Let's see. And go like current state. I can also just save it this way, where I go like current state is equal to current state, and then afterwards I can go current state is equal to temp current state. Oops, I don't need to do that. So that should probably work. Current state does not exist in this context. Yes, panel.current state. Well, we'll start with implicitly convert object to int. So I must have to use an accessor function on array lists. Come on. Okay, dot item. Is that how it is? Item? Yeah, okay. Should probably check to make sure that I actually have that. I should, but I might need this. So it's not item. Let's see how I use it then. Okay, this says I should just be able to access it. So I may just need to cast it. Just weird. I have to get this working before I leave for work. So it should be panel solution list 0, and then I should be able to just cast it as a bool array. I would hope. Oh, it's not a bool, excuse me, it's an int. It's int array. Okay, so now let's just edit this panel to where I know that it only has like one solution, right? For example. And that solution is this. So now if I hit this, well, we went out of range on the indices. So maybe I'm just off by 1. Gosh darn it. Well, it found a solution. I got a null reference for some reason. Don't know why that is. I don't think I can new an array list out here, though. I guess I can new an array list out there. Now that doesn't work though. This part, which is weird. So it's iterating through. I don't think there's actually any way I can look at that list here. I'd have to debug it. Yeah, Unity's a little weird sometimes. Part of the issue is just the passing through different layers of crap. Because if I can new that, which it seems like I can, then it should be blank here. And that should be fine. I'm gonna get rid of that, and then this should call in here, and they should get added. I guess I'll just bring up Visual Studio and debug it, because that will be probably easier. To just step through it and see what the state of the array list is as I'm going through it. Okay, so I need to go down to this guy, basically. So okay, so I know that's a solution, and it should only have one solution. When I hit this, it should breakpoint me. Okay. So it did call that. Let me okay, so this goes in here. It's looking at current state and setting it to 0. Going back up here. So it should do that until it iterates through all of the tiles. Then it should go in here, check for solution. Which should not work. And then it should toggle that last one. Either way, it shouldn't be solved. This sure is a great way to look at an array. Microsoft, thanks. Let me add it to my watch window. Does it find the solution is the main question. As of this time, it still hasn't found it. Probably should have made the thing a little, yeah, that's what I was gonna say. I should probably have made the solution a little bit different. Alright, well, we'll do that then. We'll make the solution be all off and then hit this. Okay, so it found a solution, but for some reason it found it as all on, which is really weird. I don't know why that it found that. Let me try this again, because that should not be counted as, oh, it is all, wait, no, it's all off. It's really weird. Let me try that again. So it's going in here, and what in the heck is going on? Why is the... I bet it's not clearing out the list. Is probably part of the problem. Okay, so... Because I bet array list, new array list doesn't actually, like, clear it. Because it's retarded. So we're just going to do this. We're going to go... I'm not even declaring that there. I shouldn't even do that. It should be solution list.clear. Okay. Just to make sure that works. Let's change this solution and hit find all solutions. Okay, so it should clear it out, then go through here. And hopefully count it as solved when it iterates through and finds the solution. It should be solved and then get added. Okay, so it did find it. So that's good. But show solution is not working, is the weird one. So it must just have to do with the cast there from that to the other. Even though this is pretty clearly an integer array. So let me pull up that and see what it's doing inside of the editor. I don't need that. So it should be right here. Hit F9 on that one. And then I should be able to click this. Well, it's not exactly what I wanted. Let me just set it, the breakpoint in there instead. Okay, so now that should go in here. And panel solution list. It's right, but why is it ones? Why is it ones? Why is it ones? It doesn't make any sense why it's ones. Find all solutions. F5. Show solution. Why is it ones? It doesn't make any sense why it's ones. That's really weird. Oh, it is. It's not ones, though. It's zeros. Is it all ones? Yeah. Somebody add that to the quote list. Why is it ones? Why is it ones? Why is solution list ones? Somebody tell me why it's ones. I have no idea. I don't know why it's ones. I can't, for the life of me, figure out why it's ones. Because it should be iterating through, seeing if it's solved, which tests the current state, and then if it's solved, it adds the current state, which, as far as I could tell, works. So I'm going to set breakpoints here, and then continue. Hit reset starting state, and then do this. So then this should find a solution state, but it didn't, which is really weird. Oh, okay, it's not added yet, of course. Now it's added it. Zero, 1, 0, 1. So it found the state, so it's in there. But for some reason, when I try to get it through here, it's just not even. It's just like, no, that's not happening, buddy. You're not getting that. But why is the question? Why is it all ones? Well, Donnie, you're out of your element. You're like a child who's just wandered into the middle of a movie. Okay, well, I have to go to work, so unfortunately I can't figure out what's wrong. But it seems to me like it probably has something to do with the way in which I update the panels live while you're running the game. And it's probably throwing out the data, because like I have this thing that lets me update that, and essentially that tries to keep the current state the same. And so it's probably throwing out the data is probably the issue. But I really don't know. So yeah. But it's definitely finding the solution, so I would like to personally thank Mocosmo for coming up with a very short and elegant solution to the problem of iterating through all of the possibilities. Handling broken tiles or absent tiles is pretty easy in comparison to that. It's just really just about skipping the tile. Yeah. Anyway, so... yeah, so thanks for joining me and for helping me out. And if you would like to help me out further, there's Patreon. The link is below the channel on there. I do have some people who back me on there, and I appreciate that. It's not enough to live on, though, so I have to go off to the day job now. But once again, thanks for joining me, and I hope you have a great afternoon or evening or morning, wherever you are. Have a good one. See you around.